We had this moment where we were looking out at this sort of big flat landscape, and one of the farmers we were talking to was talking about this lake that they used to draw water from. The lake had dried up. They had pumped all of the water that they could, and he sort of turned and said, you know, if we're able to grow our crop without having to deplete these resources, that's a win for us. You know, I want to make sure that there's enough water, not just for our crops, but for my grandkids who live in this town. So I think, you know, that ultimately is the sort of fuel that maybe keeps us going, is this possibility to bring something that farmers can, that, you know, they already want. They understand the problem. They just need another tool in the toolbox to be able to solve that problem for themselves and for their local community. Avalo is a plant biology company that uses machine learning and artificial intelligence to help create new varieties of crops faster than we were able to before. Our approach is unique in that we leverage computational biology. Basically, we do cool things with computers to make the process go faster, but we also use natural diversity. So all of these biological traits like increased yield and climate resilience, and even flavor and scent, we think mostly already exist in nature. So our machine learning processes are really optimized to look at that diversity, learn from it very quickly, and then bring that diversity back into our food system. What I would say to people who are a little bit wary of AI and machine learning and genetics in our agricultural system is that, you know, obviously there has been a history of technology in agriculture that sometimes has really delivered a lot of benefit, and sometimes that benefit has come at the expense of smallholder farmers or family farms, or even in some cases consumers. What I would say is that it doesn't have to be that way. We can rethink how we use technology in our process, how we use artificial intelligence, and how we use genetics to work with the agricultural system that we want, and not necessarily against it. I would also just add that, you know, even though we use genetics as part of our process, genetic sequences are used to train our machine learning algorithms. We are actually not doing genetic modification as part of our product strategy. So even though there's this genetics and technology focus in the company, at the end of the day, you know, people are sitting in a greenhouse taking two flowers and rubbing them together to produce new seeds, just like we've done for thousands of years. And so I think it's been really exciting for us to focus on how technology can benefit that process rather than changing that process over to something different. So we actually have two sets of customers. On the one hand, our customer are farmers. Farmers are running their own businesses. They are trying to make ends meet. They often have very little profit at the end of the day. And we're trying to bring in resilience to the environments that they now grow in, and also higher value traits in the crops that they're growing so that they can make more profit off of the land that they already farm, that they already maybe own or lease. And on the other hand, we have users of agricultural products, and sometimes that's consumers who are eating fruits and vegetables, but sometimes those are multinational companies that are using cotton, for example, in their supply chain. And so we actually realize that we have additional value that we can bring by looking at both of those sets of customers. We have this mandate, I think, from the far end of the supply chain to bring carbon footprint as low as humanly possible, which is great. So then we've had to go to farmers and sit down and look at their budget and say, what costs you, the farmer, money? What brings in money for you? And where do you use a lot of carbon? So for example, in Texas, in cotton fields, those cotton fields that are irrigated are often irrigated by a well, and that well has a pump, and that pump is powered usually by 1 or 2 diesel engines. They also have to fertilize their crops, and most of that fertilizer is synthetic. Synthetic fertilizer is also made from oil. So then the challenge becomes incumbent on us. How do we create a variety of cotton that can grow without additional water input. So we save that carbon and we ultimately save the farmer money and we rely exclusively on rain. And how do we create a plant that is productive in a setting where it might not be getting a huge amount of fertilizer, it might not be getting a huge amount of water. And so we know that cotton in the wild can live without additional water input, can live almost exclusively from the rain. And we know that that fiber can often be very high quality. So how do we bring in what's really good about the production systems we have today, which is we're able to produce a lot of cotton, and also introduce these resilience characteristics from nature back into that system? I think I would say that I think of design from a scientist's perspective and not necessarily from a designer's perspective. We have spent a lot of time trying to understand design as it sort of already exists in ecology and in nature, and try to replicate those designs as faithfully as we can in a commercial or a scientific or a production setting. So for example, in our greenhouses, as I mentioned, we have to rub flowers together. And so naively, we started out like every other company started out. We laid a bunch of plants out in a grid on a bench, and somebody would go around and we would sort of rub these flowers together and keep track of which ones we crossed. We had this idea at the company, well, what if we just bring in bees and let bees move the pollen back and forth? It turns out doing that process, replicating what was happening in nature, saved us money. I think we saved about $500,000 a year in labor costs. It was more efficient for us in creating the diversity that we wanted to see and that we wanted to select from. And it was a lot more fun to watch. So I guess that is a little bit of how we try to think about design and how we're trying to understand design. I would say our biggest product design challenge is to hold together the complexity of the agricultural system in our heads while we're trying to build our products. And what I mean by that is I think there are a lot of competing demands in the agricultural system. There's what farmers need to do to be able to grow a successful crop and deliver food and fiber and fuel to customers. There's what consumers are demanding, which is actually really inspiring because I think people are asking for a lot more sustainable products. And then there's what we want our impact to be. What is the impact on the ecosystem and what is the impact on nature? And that is actually a complex set of design challenges. It's really, I think, forced us to be very thoughtful, even though the technology can help us produce products very, very quickly. I think it's been important for us to sort of remind ourselves to stop for a minute and actually think before we start implementing things. What is going to be the downstream impact for each of these three spheres? And how can we design something that isn't treading too heavily on each of those areas? What I hope that our customers experience after using our products, so if you're eating Avalo's broccoli, for example, of course, I would love for a consumer to think that it tastes better and that it's fresher and that it's more presentable. But ultimately, I think the benefit for us is that we're able to grow that food or grow that agricultural product with a lower carbon footprint, with an increased resistance profile to extreme weather events. And so in some ways, I hope that experience for the consumer is exactly the same as what they had before. Maybe they don't even notice that they're eating something that is climate resilient and that is more sustainable. And that, I think, is what we think is the key to expanding the scope of our impact. I think that we're sort of past the point where we can say sustainability is something we want in sort of the abstract, and I think we have to get really tangible. Do we want a lower carbon footprint per acre? Do we want lower pesticide usage? Do we want less or irrigation? Which of these things matter? I guess what we need to really succeed is commitments from both sides of the supply chain to work towards, I think, a difficult but ultimately worthwhile agricultural future. I think if my wildest dream for Avalo came true, I would hope that the next generation of agriculture preserves the features that I think we all want to see in our agricultural system. You know, small family farms are still possible, nutritious food and grain and fiber are coming out of that system, and that people can have a better appreciation for where nature and where agriculture are delivering things to them. And, you know, maybe that is an awareness that is more present in people's lives.
Allelo's mission is to use the power of design to help build a more equitable and regenerative economy. And something that I find super compelling about what these founders are doing is they are building that future economy.
There is so much innovation here that R&D is no longer really the bottleneck. It's the demand side, making it so that this is the inevitable next step, because this is how the world of tomorrow is going to run.
Yes, it is.
What I hope that our customers experience